So Lisa, are you ready to teach that switchgear class next week?
Yeah, it's the weirdest thing though. I had a nightmare last night that you and I were in that Jurassic Park movie.
What?
Yeah, you know the part where the lady's trying to close that old Westinghouse circuit breaker to keep the dinosaurs from escaping?
Yeah, I remember that part.
Well, here's the problem. You were supposed to do maintenance on that breaker, and guess what? It didn't work.
Me?
You.
Hurry up, Lisa! The dinosaurs are getting out!
I'm trying!
Why aren't you closing the breaker?
It's not working!
Oh, sure. Blame me. You teach the class too. You could have done maintenance on the circuit breaker, not just me.
Yeah, I guess you're right.
Welcome to Eaton's Power Systems Experience Center. In this video, we will talk about the type of electrical testing and maintenance that we teach here at the PSEC to our own field service people as well as our customers. We will also address key safety considerations when doing maintenance and testing. There are three major benefits of testing and performing preventative maintenance on electrical equipment: improved safety, increased reliability, and avoidance of equipment damage. Outages are a major problem for anyone using electrical equipment, and usually, the more power you use, the more costly the problems are. A planned outage can be controlled with expected costs and expenses, but an unplanned outage is often significantly more costly and results in much longer downtime. Preventative maintenance during planned outages drastically reduces downtime and operating costs. In the next section, we will discuss some of the most common types of test equipment and procedures used for electrical testing and maintenance, including Megger, high pot, ductor, high current injection, and thermal imaging.
Electrical equipment requires good insulation to work properly and ensure the safety of personnel and equipment. Over 80% of electrical maintenance testing involves evaluating insulation integrity. A good insulator will have a high resistance, and a bad insulator will have low resistance. The insulation of a piece of equipment is never as good as the day it leaves the factory floor. Insulation quality can get worse over time because of different environmental conditions like temperature, moisture, humidity, and dust or dirt. Along with proper insulation, ensuring appropriate distances or air gaps between current-carrying conductors and its metallic shielding is important. If the quality of insulation or space between phases or phase to ground are not tested and verified, it could result in system or equipment failure or danger to personnel. There are a couple common tests that can be done to verify these concepts. One test would be called an insulation resistance test. That is also called a Megger test because of the brand name of the common equipment used for this test. A Megger test uses an applied DC voltage that generally would be 500 volts DC or 1000 volts DC for low voltage equipment, and about 2500 volts DC or 5000 volts DC for medium voltage equipment. The values will be typically measured in ohms or megohms, but can go up to gigaohms or teraohms. Because testing is done with DC, inductance and capacitance are not evaluated, and only the DC resistance is measured. Typically, the Megger test is done first to verify basic insulation, and then the high pot test is done, which evaluates the AC integrity of the insulation. A dielectric withstand test, also known as a high pot test, applies a high AC voltage between an electrical device's current-carrying conductors and its metallic shielding or ground. A high pot can also be used to test the vacuum integrity of a vacuum bottle. The leakage current associated with a high pot test will typically be milliamps. While a Megger test is done to check for large values of resistance on insulation, a contact resistance test or ductor test is used to measure low resistance values between any two conductors or electrical connections, such as circuit breaker contacts, cables, or bus bar connections. For this test, you want a low resistance. This resistance is added to the total resistance of a system, so typically it is better to have a low measured value. Some things that may contribute to bad or high ductor readings may be dirty or loose connection points, or dissimilar metal bonds like copper and aluminum. High resistance at electrical contact points or connections typically result in overheating, voltage drop, and losses. Overheating of electrical equipment can be found by thermal scanning, often called infrascan testing, to look for loose connections or other problems. This is done by using a thermographic infrared camera to detect infrared energy or heat and converting it into an electronic signal. This signal is then made into a thermal image that can be displayed on a video monitor showing the temperatures of components in the picture. When one part of the equipment exhibits a hot spot, it often indicates a localized problem, like a loose connection or overload. Periodic scans help maintenance personnel evaluate and trend problem areas before they result in a failure or arc flash issue.
The trip system on a circuit breaker is made up of several different components that at least include a programmer or trip unit, current transformers, and direct trip actuator or DTA. The typical methods to test the proper functioning of the protection system on a circuit breaker is by secondary or primary injection testing. A secondary injection test is done by connecting directly to the trip unit and injecting a low amount of current to verify the operation of the trip unit and direct trip actuator, but does not apply any current directly to the circuit breaker's primary contacts. A primary injection test is done by connecting a circuit breaker to a high current test set using the primary contacts. This is a much more reliable test because it pushes a large amount of current through the entire breaker. Primary injection will not only test the trip unit and direct trip actuator, but also the current sensors and opening of the circuit breaker's contacts. There is a certain range of acceptable tolerances for a circuit breaker to pass this test given a fixed amount of current versus time compared to a particular time current curve, or TCC. Testing would typically include evaluation of long time pickup and delay, short time pickup and delay, instantaneous pickup, and ground fault settings. For arc flash reduction, maintenance mode settings should also be evaluated. There are several other functional and electrical tests that may be performed on electrical equipment to ensure safe and reliable operation. Transformers require special testing to ensure that they operate properly and will continue to operate for their expected life. Transformer testing typically includes TTR, or transformer turns ratio, and Megger testing for dry type transformers, and also includes oil testing for liquid filled transformers. The oil testing evaluates contaminants and helps to determine the health of the transformer. For larger transformers, bushing power factor testing is done to verify the integrity of the insulation of the bushing. This test is often referred to as Doble testing, as Doble is the manufacturer of the typical equipment used for this testing. For other equipment, including circuit breakers, contactors, and other control equipment, using an AC or DC variable power supply, tests are performed to verify the operation of all the electrical components on a piece of equipment, including motors, relays, contactors, coils, and switches. Some of the tests include communication testing, including testing and verifying all communicating devices to ensure that they are sending and receiving information as designed. Relay and trip unit functional testing, which includes testing the functionality and verification of settings of these protective devices to ensure expected operation. Continuity testing is a more simplified test compared to ductor testing, where wires, fuses, and windings are evaluated for point-to-point continuity to ensure expected connectivity. For this test, you verify that all wire connection points are landed in the appropriate locations when comparing them to schematics. Control power transformers, or CPTs, used for supplying power to control equipment, and potential transformers, or PTs, used to monitor voltage, must be checked to verify expected voltage levels and functionality. Auxiliary contacts must be tested to verify that all contacts make and break at the correct time. Also, contact resistance should be verified to ensure you have a good low resistance for each contact. Finally, timing testing will help you verify that contacts open and close in the proper amount of time and in sequence after receiving a control signal.
Whenever electrical tests are performed, safety is essential. Here are a few key considerations and procedures you must think about before proceeding with your test. First, a pre-job briefing is done and the job is discussed. Electrical and non-electrical potential hazards and countermeasures are identified, such as what PPE to wear, boundaries to be set, and tools needed for the job. Personal protective equipment must be identified specifically for the job site, considering potential arc flash levels and shock hazards. Boundaries are evaluated for arc flash and shock hazards, and the more restrictive boundary is set for the job site before doing work. Next, you must create an electrically safe work condition. This includes disconnecting and/or isolating sources, lockout, tagout, or LOTO, checking for the absence of voltage using live dead live or LDL procedure, and applying grounds as necessary. Live work permits are required whenever repairs or modifications are performed live, or working on equipment where the incident energy is above 40 calories per centimeter squared. This also includes loosening or tightening terminals over 150 volts.
Many pieces of electrical equipment, like circuit breakers, require mechanical maintenance to operate properly. It's like changing the oil in your car. You can drive for many months without service, but once you do have a failure, you may have irreversible damage to the vehicle. The following are some of the key mechanical maintenance procedures important to safe and reliable operation of your equipment. If the lubrication of electrical equipment is not maintained, it can cause equipment to misoperate or not function when needed. This is generally a major problem with power circuit breakers since they have many mechanical parts that need to move freely. Whether a circuit breaker has a high number of operations or very few operations, it can be problematic. A high number of operations can result in excessive wear to mechanical components. A very low number of operations can result in the hardening of certain types of lubrication on pivot points as well as bearings. With thorough inspection and proper preventative maintenance, electrical equipment has a much greater chance of operating correctly. Visual inspection of electrical equipment can help prevent possible downtime. By finding a part that is damaged prior to being broken, can eliminate what might create an unplanned outage. Simple cleaning of electrical equipment is very important. Some environments may create layers of conductive dust or dirt that can create a major problem for electrical equipment. At medium voltage levels, this can become a path for electricity to flow and create damage to equipment or possibly even an arc flash event. Finally, during maintenance, be sure to tighten or torque connection points and hardware. Most issues occur from loose connection, but sometimes over-torquing can be problematic as well.
We are often asked, what is the appropriate time interval for testing electrical equipment? The answer, as with many things, is it really depends. Each system is unique, depending on the environment, the use of the equipment, and other factors. Our services group can help you determine what is right for you.
At Eaton, many of these tests are performed at our Power Breaker Reconditioning Centers, or PBRCs. We have 6 of them located in various areas across North America, and we can help you test the integrity and upgrade power circuit breakers and other electrical equipment. With the largest field service organization in the business, our service group can also come to your site to test your equipment.
If you want training on evaluating your electrical equipment or to learn more about electrical testing and maintenance so that you don't have any nightmares about it, contact us or your local Eaton representative to schedule a visit to the Power Systems Experience Center today.